HVAC 360 is brought to you today by Construction Paper Products, who wants to remind you that Valentine's Day is right around the corner. So here's a few samples of sentiments straight from our greeting card division to help you make that someone special's day. Roses are red. Hard hats are white. Your submittals were late, but I still think you're all right. Or this gem. You had me at, I brought donuts. And for those of you with more of a sweet tooth, our candy division has conversation hearts perfect for those awkward engineers in your life to help them with small talk at the next project meeting or site visit. They'll be forever in your debt. Construction Paper Products. We help build strong relationships. Hey, what's up? Welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. Each week, I'm either sharing lessons learned from the field or talking with industry experts. But I don't stop there. I want to encourage you to double down on your weekly dose of HVAC knowledge by hopping on over to HVAC360.com and join my growing community of people just like you. And as an added bonus, you are going to be among the first notified of a free webinar series that I'm launching in early 2019. Now, the only caveat is that there's only going to be 100 seats available for each webinar, but it will be available on a first-come, first-served basis. All right, so what's up for this week? This week, I wanted to share some information about the building enclosure. Now, this is something I touched on a little bit ago, one of the previous episodes that I did, and one of the listeners suggested that I do a little bit more on this topic, and I thought it'd be a great idea. So here it is. So what exactly is the building enclosure? Now, it's sometimes referred to as the building envelope, but I think nowadays they're going towards the building enclosure being the proper name for it. Not like you're going to be wrong, but I'm just saying building enclosure tends to be what everybody's calling it nowadays. Now, in its simplified form, if you have no idea what I'm talking about when I talk about building envelope, building enclosure, it is simply put, it's in the simplest form, 4 walls, a roof, and the floor. So that basically contains the exterior of the building, where the building essentially meets the environment. One of the things I just wanted to point out, I'm not really be covering the floor, even though it's still a critical point or a portion of the building enclosure. I just want to cover the other topics for you instead. So, I guess the first thing, you have to understand that the building enclosure tends to be the purview of the architect. A lot of mechanical engineers are going to have some say and some input. It is the architect who is really in the driver's seat. You might dictate saying, hey, you have to have this sort of R value, this sort of U value for your windows, this many inches of continuous insulation. You may know the energy code better than the architect, and frankly, you should. But that doesn't change the fact that there really should be more interaction between architects and engineers when it comes to the building enclosure. So that being said, let's talk about an architectural drawing set. Now, I guess there's two things. There's with any sort of construction project, you're going to have construction documents that, in essence, what you're saying there is both the construction drawings and the construction specifications. That's what contractors are going to be bidding on. So let's talk about the construction drawings a little bit first. So the first thing you're going to run into is you're going to run into the cover sheet. This is going to be your roadmap. It has a list of drawings, and really don't underestimate it. Just use it. I mean, if you're not used to using maps, start here. You'll understand the framework, how everything's laid out. If you know what you're looking for, you can easily find it and then go to that number. Not all jobs are numbered or labeled the same way. Some of the series might be mixed up, and it just helps you identify and know where you are. So, I think one of the critical pieces, and I kind of glossed over it a little bit, is the series. Now, drawings are created in series. And what I mean by that is that you're going to have the 100 series of drawings. So it's going to be like A101, A102, A103, and so on. They're going to be identified and labeled in a certain way based on kind of what fits the building shape, how many different pieces are fitting on it. But it's whatever you have at an 8th scale, whatever that fits on a drawing rather nicely. So that's going to be an architect determining that. Everybody's going to follow suit, but those are the series. So you're going to have a plan series, you're going to have an elevation series, you're going to have a wall series, you're going to have a bunch of different series. And when you look at the cover sheet, you're going to be able to determine what that is, what you're looking at. So first off, I guess when you identify that, you're like, okay, let's start with the plans. So when taking a look at what are some of the details, you could just jump to the details sheet, but you really wouldn't have any idea of where those details occurred, how they interrelated with the rest of the drawings. So you really want to start with the plans. So you go to the plan series and you talk about that. Now the plan series, what you're going to see is that they're labeled. There's going to be section cuts through the plan series. So what that shows you is it says, okay, there's this detail on this drawing. You're going to see the cut of the building, the plan in this direction. And I guess it's a little bit ambiguous what I'm saying, unless you truly understand it. But if you're looking at a floor plan, you're looking at it from the top, and then when you have the section cut, you get to look at it from a side view. So you'll actually see a cut through the building. You'll be able to see some of the roof structure. You're going to be able to see where the anticipate the ceilings are going to be. You're going to see it from a side view. So that's a section view of a plan. Now, when you look at the section views, that's not going to give you enough detail. That's, generally speaking, they're going to have differences in elevations. They're going to say this is how different pieces and different components of the building interact with each other, but it's not going to really tell you a lot of detail. So, but on these elevation on these sections, section drawings, you're going to be able to go, and there's going to be dotted lines that say, okay, this exterior wall on this side of the elevation, it's going to be located again. It's going to be this detail on this drawing. So you kind of see the pattern forming here. So when you go to the wall sections, that's going to be typically, you're going to see a bunch of different wall sections lined up, one after another. That's going to have a lot of the detail of what really makes up that wall. You're going to be able to identify some of the control layers. Talk about control layers a little bit later. But you're going to be able to identify the control layers and some of the other components. This is where you're going to start to see some of the insulation. That's typically, as a mechanical engineer, that's the first area that I kind of, really target in these wall sections. You're also going to be able to see some of the wall roof interfaces, some of those things. And if there's something particularly that you'd want to understand, say, for instance, it's going to be a window-wall interface or a parapet. Like at the top of a wall, you're going to have where the wall kind of interfaces with the roof. You're going to have a parapet detail. So a lot of the interfaces or the details are going to be identified on these vertical wall sections. So there again, it's going to label, okay, it's going to be this detail on this plan. So that's when when you go to the details, that you're looking at the right detail for the right, just the right detail for the right application. So you're going to be identifying in the right area. So now the thing with the details, I think that's important to identify or important to know, is that not everything is detailed. This is part of the problem. You don't have enough time as an architect to detail every different condition. You are going to detail the typical condition. Now, that's kind of a downfall, because the non-typical conditions, that's where you're going to have the problems. So as somebody doing, building enclosure commissioning, that's what I want to look for. What is not being detailed? Where are the problems going to occur, among other things? So that's the plans. On the specifications, that's really where you're going to see more of the glazing, where you're going to have the U values, where you're going to have the shading coefficients, all that information. That's tucked away in the specifications. So you're going to have to look at the 07 series for the specifications to be able to identify those. So another thing to look at, and this is kind of a little bonus tip, when you're looking through these different things, different series of drawings, there is going to be a series of drawings called wall types. Now, if you're looking to identify, where's a smoke wall, what's a firewall, that's going to be on the wall types. That's going to be detailed and identified on these wall types. And it looks like some of the wall sections that you see, but it's a lot simpler because it just says, here's the makeup of that wall. So they're a lot shorter. They don't really have a lot of the interfaces. It might have the interface between the ceiling and the wall and how that's detailed if it's supposed to be smoke tight. So it's really tight, it's really tight to the deck, and it shows caulking in between the wall and the roof deck. That's some of the things that you might be able to identify on the wall types sheet. But if you're going through this exercise, identify where the wall types are, where the wall type sheets are. Now, where are they identified? Well, that way you have to go back to the plan drawings. Those are typically, when you look at the plan drawings, there's going to be little labels to say, hey, this is wall type A or wall type C, and you're going to be able to identify what goes where. So do that little exercise if you ever find yourself in possession of a sheet of architectural drawings. Try to go through and figure out, how many inches of insulation there are, where the wall type sheets are. Sometimes they do identify some of the wall types where it's a 2-hour wall, 1-hour rated wall, where there's some sort of fire separation. A lot of times they will kind of identify that on the drawings. But if you're unsure, just check the wall types and figure that out from there. All right, now let's talk about control layers. So we identified exactly where we find this information, but it's really important because we have control layers. And what I mean by control layers, there's a bunch of them. The most important ones, there's 4 critical ones, at least in my point of view. There are other ones that could be as equally as important, but typically not on your average building. But your control layers are the air barrier, your water barrier, vapor barrier, and your thermal barrier. Some of the other ones might be, sound barrier or safety layer. Those are different types of control layers. But it's very important that a lot of times that these be continuous. So you want your thermal layer, you want that to be continuous. It's, by code now, most nowadays, they have continuous insulation requirements for most climate zones. So you're going to have a continuous insulation layer. So those are going to be identified on the drawings. But again, they need to be continuous. And that's identified typically on, again, the wall sections. Now, you'll have things like the air barrier. The air barrier needs to be continuous. And the air barrier is one of those critical components that needs to be, that really needs to be, for lack of a better term, continuous. That's really important. Let me, give you an example. A building should be as tight, like a balloon. You should be able to, when you pressurize it, when you put air into it, it should be able to withstand the pressure of what you're putting into it. So it's continuous. The balloon is a continuous air barrier. Now, what happens when you're blowing into the balloon and somebody makes a hole in it? Well, you have a lot of air leaking out at that one point. And in fact, it's very critical with air barriers because a poorly installed air barrier is actually worse than no air barrier at all. I've heard that said, multiple times. Why? Because when you have no air barrier at all, at least that allows the structure to dry to the inside, dry to the outside, depending on climate. It's really not thermally efficient, but what you don't do is you don't trap water. So when you're mostly continuous, that doesn't really help you. You need to be completely continuous. And we'll be able to identify some things where that happens when I talk about the roof and the walls. Let's go and talk about the roof. So on the roof, you want to know a couple of things. Obviously, you want to be able to check the insulation thickness. That's going to be on those wall sections again, right by the parapets, things like that, the roof-wall interface. You want to be able to identify if the structure is sloped, so you're able to keep the constant insulation thickness, or whether or not the structure is flat, in which case you need to slope the insulation. So you need to have an average insulation of so many inches. Now that's sort of something critical that you want to be able to identify. Now, parapets, equipment curbs, that's height is important for the roof itself. You want to be able to keep in mind that really the maintenance on a roof is in replacing it. So you don't want to have a equipment curb that is too short, not only from the standpoint that, hey, you're going to have, depending on your climate zone, of course, you're going to have snow drifts. Things might be, if you don't want something too small. And this is typically covered in most company policies. They kind of come up with, okay, we're going to have a minimum curb of 12 inches or minimum curb of 18 inches. That's going to be your minimum. Remembering that if that goes to the roof deck, so 18 inches from the roof deck, so you're going to have your insulation and your roofing products that come up from that. So 18 inches might sound like a lot, but by the time, especially if you have tapered insulation, that can eat up a lot of that 18 inches. Now, why is that critical? It is critical because typically you're going to have a warranty on this roof, and the warranty might dictate exactly how much of a vertical distance you have to have in order for it to be warranted. If it's less than that, they might think it's a risk of leaking, so they might not necessarily warrant the roof. And we certainly don't want to void the warranty of the roof. Along with that, know that you really want to make sure that you keep a clean area. When they have the final roof laid down, it just boggles my mind. I see, screws everywhere, different fasteners. It never ceases to amaze me, the contractors. I don't think I've ever seen a contractor pick up a screw. But it's really critical because that's the real area where you're going to be able to get that leak. You're going to puncture the roof membrane, and you're going to have issues there. Typically, the field of the roof, just like the field of the wall, those are generally the safest spots where you're not really going to have too much of an issue, obviously, unless you puncture it. It's really the corners, the edges, where you're having the most bulk moisture. That's where you're going to have a lot of the issues. So that's what you want to make sure that you address that, and you don't necessarily impact that a lot. Now, a lot of that has to do with a roofing contractor. That's not necessarily a mechanical contractor's purview of what they do with those special scenarios. But just understand that if for some reason something happens to the roof, that you should have the roofing contractor fix it, and don't try to fix it yourself, because again, the roofing warranty will state that the roofing contractor that's approved by the manufacturer should repair it. So even if you have a roof that is 5-7 years old and something happens to it, you want to go back to the original roof manufacturer and have somebody that they recommend repair it. So, along with that, you want to make sure that you use the walkway pads. A lot of the roof, that's another area where they kind of double up, and it's a little bit more a grippy surface, so it helps you walk. Some of these white roofs are really, really slick, and I know I've a number of times I've almost slipped and fell walking up on these white roofs. All right, now let's flip over to the walls. Some of the insulation, again, can be found on the wall sections. Now, I guess here's a couple of things you want to watch for when you're dealing with or you're anticipating problem areas. One of those is the exterior structures. So when you have overhangs, when you have balconies, when you have things sticking out of the face of a wall, those are always going to be potential areas for problems to occur. Also, you want to watch for exterior lights and plumbing, because at some point in time, it has to go from the inside to the outside. So that means it's penetrating the wall at some point in time. Now, that becomes especially problematic because they have this can actually occur after the air barrier has been installed and completed. They poke holes in it, and now it's not continuous. So that is an area where leaks can occur right around those areas. So it's always good to have some sort of to educate yourself on the importance of what to do when you're going to penetrate an exterior wall. What are you going to do to patch it and repair it so that it doesn't lead to problems in the future? A lot of things too, you take a look at, you don't really want to have to rely too much on tape or caulk on the exterior enclosure. A lot of times you're going to be taping seams, or you're going to be caulking seams. Caulk doesn't last forever. About 5-10 years is the average, especially when you have it exposed to sunlight and the elements. It tends to crack, and a lot of times it just needs to be replaced, just like everything else, and it needs to be in a position where it can be maintained over time. That's why it's so critical when you have different components in the building envelope that you're going to have those permanent areas like flashing and detailing. Those are going to be as rock solid and as hardy as possible. You want to make sure those things are durable. There is also a compatibility issue with some of these things. Some of these PVC and asphalt, they don't really play well together. They tend to fight, and PVC tends to lose in that fight. So that's a lot about the walls. And I'm going to go into a little bit more specifics if that was kind of a little bit too esoteric and not necessarily too helpful for you. But I'm just telling you some of the things that I look for when I look at the wall drawings. Now, let's talk about something a little bit more realistic. What really happens? So what are some of the issues that you can develop when you have issues with the roof, the walls? And I'm going to highlight, I guess most of these things are related to your walls, but here's some basic areas. A lot of areas, like I said, where errors occur are between the conditions that aren't detailed, and that usually includes where they're interfaced. So it's I guess there's three things that happen in that scenario. They're either not detailed, they're detailed incorrectly, or they're really hard to actually construct that detail. So constructability is a huge issue. You can think of, how many times have you seen somebody try to cut drywall and, fit it to a fluted deck? It just is one of those things that you really have to be an artist to be able to get it really exact, really close. And it's something that's not necessarily easy to do. So, obviously you can minimize caulk if you get it real tight, but it's when you're detailing around beams and things like that, a lot can go wrong. A lot can be incomplete. So, on the water side, I guess in general, when you're speaking about freezing and thawing, and we have this conversation with some of the members of the membership, the HVAC 360 membership, is that heating water isn't really subject to a lot of freezing. Unless you have a power outage, and then it will be. A lot of times you're going to be dealing with freezing conditions in areas that are either in a vestibule, so it's outside, it's semi-outside, or it's close to the perimeter. So you have issues with obviously with the sprinkler system, where that can freeze. You also have cold water piping that either may be going to a hose bib or it might be serving a sink on an exterior wall. Those are kind of the areas that are potential freezing conditions that you want to be able to watch out for. So if you don't have the insulation, or there is a leak in the air barrier and you have a lot of air flowing through some of those exterior walls, that can be an issue with freezing. And a lot of times, that's, again, when you get freezing conditions and it's cold outside and there's a break, that just makes everything miserable all the way around. So, but water breaks are not the only examples of this. You have ventilated overhangs. There's conditions where there was a ventilated overhang and it leads into the inside. Again, this is where a lot of the penetrations, where you might have lights in a ventilated overhang, and wherever those lights penetrate, that's going to get back into the interior, and you're not going to be able to easily see that. So that's one of some of the areas that you could potentially have issues. Again, maybe not freezing issues, maybe it's just comfort issues. But again, if you have air driving into a building, on the windward side in the high winds of winter, it's going to get very uncomfortable. It might be unoccupiable. So it might be just as bad as a mean radiant problem that we've talked about in the past, but it's an issue with, being cold. And, the real kicker is I've had scenarios where typically like corner offices, they only put important people in corner offices, and that's where most of the issues occur. So if you have situations like that and you have a cold corner office, obviously that's going to be a non-starter. But I've had scenarios where they're like, you know what, your HVAC system is garbage, it's not keeping up, it's always cold in here. And then when we look into it a little bit further, it's actually the building enclosure that has failed and not the system. No amount of air conditioning or heating can compare or compete with the power of the exterior environment. So that's why we want to keep everything continuous, everything, real nice and cozy, air barrier continuous, things like that. And that really helps. Now, sometimes you have other issues that occur, and because you have what is called a thermal bridging. So you have conduction along structural steel. If it's going outboard, if there's structural steel that is not thermally broken, you are going to have thermal bridging, and you are going to have this conduit of cold. It's not going to be cold air, but it's going to be cold steel. And you know what happens if you put, warm, humid air next to cold steel? It's going to sweat, it's going to drip, and it's going to cause issues. So it's not that moisture is necessarily getting in from the outside. It's that the steel is being it's being cooled, and it condenses water, which I've in a couple of cases that I've seen has actually happened. It's been an issue. Breaking. Doing a thermal break on a piece of steel is not easy, and it is certainly not something that you do after the fact. There's some things that you can do in retrofitting certain problems, but I tell you, if it's not thermally broken and it's going through the exterior wall, if it's going through that thermal layer and not being thermally broken, that is a bad situation waiting to happen. So that's one with a thermal break. Also, with a lot of times, you have these overhangs. I've had a case where it's like really cold in this vestibule, and I'm like, why is it really cold? And I poke my head above the ceiling, and I see the drywall between the vestibule and the overhang that's right outside. It has been cut out, and it's been like an 18 by 18 inch square. About the size of an access panel, but nobody put an actual access panel in there. And it looked like somebody was doing some work after the fact with electrical, or somebody was trying to get in there and do some work in the overhang. And they just had this, and they just left it. They didn't think anything of it, but everything's ventilated. Most of the fixtures, most of the lighting fixtures that you're going to put on the outside are going to be ventilated, which means that the plenum that they're cut into is going to have, for the frigid cold air, being able to just get right in there. So there's really no separation between that and the inside there. So let's see. So drywall conduit, conduction across beams and around beams. Again, really hard to detail around beams. Those are some of the things that I see when I talk about the enclosure. So we've kind of gone through how to analyze the different drawings, how to kind of step through them and look for exactly the information that you're trying to get. If there's an air barrier in place, if there's a continuous insulation in place, you now know how to kind of step through the set of drawings to identify those. You know exactly kind of what I look for and some of my feelings on the roof and the walls, and some of the basic issues that I've seen around this. All right. Well, thanks so much for listening. I hope this was helpful. I know if you know somebody who's looking for more information about this topic, consider passing this episode along. If you're not a subscriber, consider joining the HVAC360.com community, people just like you. And lastly, I would be greatly honored if you not only share, but rate and review the podcast on Apple Podcast. And if you do so, as always, I'll give you a shout out. Well, that's a wrap of this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.